Hi everyone, I'm Daniel Elliott and welcome to this video on Unreal Engine Spline Components and Spline Mesh Components. These are new features in 4.3. There's a preview version out right now which I've downloaded and had to play with. There isn't any documentation yet that's been released about how to use these new components, but I was able to put together a small example. It's really good for it's really good for just having splines in your scene and using them as a general layout tool, and it's also good for using the splines to create geometry, so we can have things like roads and bending geo that follows the spline curve. So the first thing I'll do is I will load up the engine. And I'll create a new project, blank, and just call this Spline Mesh example. So we'll start with a blank scene, and I will create a new blueprint because this is where our components will be held. So we'll just make it based off of an actor, because all that needs to happen is it needs to be placed in your scene, and an actor based blueprint has all the functionality we need for that. So let's call this Spline Component. Actually, we'll call that Spline Component BP. Open that up, and the only thing that's in this blueprint right now is a scene component, which contains transform information for moving it around the scene. So let's add a new component, and we shall choose under shapes. There's this spline component, and what this does is it creates a basic spline with 2 points, and I will show. And if we just save this and compile this, I'll show you how we can edit this in our scene. So we have our blueprint here. We should drag it into the scene, and now we have an instance of that blueprint class in the scene. So the first thing we can do is simply just, if we have the, I think I accidentally duplicated that, so I'll delete that, select the original, and I had Alt selected when I dragged it up, so that's why I created a duplicate. So we can simply have it selected in the scene outliner and drag it around the scene, just like any other object or actor. We can also click on individual points on the spline and drag them around, and they now move independently of each other. But if we now go and select the main one in the outliner, actually that's not working for some reason, but if I deselect and reselect the spline, we can move the whole blueprint again. You have to remember that if we're clicking on individual splines points, that is not the same as moving the spline blueprint. That's a separate thing, and I think we can see that when we click on the points. There's this little red cross, and that represents the scene component that's in the blueprint, which allows us to move it around the scene. So yeah, we can click on the points, drag them around anywhere in the world. If we want to create a new point, what we can do is we can hold Alt and drag, and that will create a new point on the spline component. And we can even do that to individual ones. And as we can see, as we drag them around, the tangents of the curve automatically update themselves, so there's always going to be a smooth transition between the points. Now we can actually go and enter our rotate tool and rotate those tangents individually if you want to, and you can even scale them so that the influence of the tangent has an effect. The more further out, the more you scale it. So that's just a brief overview of the actual spline components themselves. Now the other thing that's in the 4.3 is spline meshes. So what I'm going to do is I'm going to create a quick mesh that we can import into Unreal. So I'm just going to open up my little modeling program here, and we can create a grid, and I'm just going to make it just divide it by 8 in X and Z, or X and Y in Unreal, and we shall create that. And what I'm going to do is just extrude it up a little. So I'm just going to go into face mode, extrude it up, so we've just got a little bit of depth there. And I'm going to export this save selected object as an OBJ, and I'm just going to save this in a folder. And we'll just call this grid 8. So let's go and try and import that back into Unreal. So import, go to where we save that, import as static mesh, import, failed to import. What happened there? Import failed. It's interesting. Maybe it wasn't selected when I imported it. We'll replace that. Import grid A, import. There we go. So now we have this asset. Let's just quickly save the level. Save as map1. So if we look at our static mesh, do we have one? It's there, but it's very small. So let's go back and scale that up in our modeling program. File, save selected objects, and we shall replace that. And we can simply re-import that. Re-import. And now we have, I think the normals are facing the wrong way there, but that shouldn't matter too much. So now we have this static mesh imported. If it was an FBX, that would have come in at the right orientation, but because Unreal swaps its Y and Z directions compared to programs like Maya, then it comes in the wrong orientation, but that won't matter for now because we can fix that later on. So in the blueprint, what I'm going to do is I'm going to go to the components, add a new component. There's a new one called Spline Mesh, and the Spline Mesh takes a static mesh as an input. So here we can choose our static mesh, and this here we can see it's already being affected by deformation. And the way that happens is the Spline Mesh component has a start position and end position, and start tangents and end tangents. And what that does is it takes the static mesh and it deforms it between those 2 points. So we can see that the end position here is at 100. I think if we were to change this, then yeah, you can see that the I think because of my normals you can't see it on this side, but here we can see that the mesh is being deformed between these 2 points. So the end position is here and the start position is here, and the mesh is simply being stretched. The tangents, they control the direction of where the deformation is happening. So if I change my tangent, we can see that well, it's hard to show this without it. I'm having a bit of an issue here. There we go. So if I start changing these, then we can see the mesh deforming in this component. So you might be wondering why it's called a spline mesh, because at the moment there's no spline here actually controlling this deformation. I think that the Spline Mesh component, it's a bit I wouldn't say misnamed, but it's deceiving because you expect that it will come with a spline inbuilt, but it's more to do with the way it's intended to be used, where these start positions and end positions and tangents can be controlled with a spline. So if I set this back to default, then we can go into the graph, and I will show you some helper functions which can help you control this static mesh component. And in fact, we don't actually need this Spline Mesh component by default in the blueprint, because what we're going to be doing is creating that Spline Mesh component on the fly in the blueprint, in the construction script. So what we're going to be doing is we're going to be getting our spline that's in our blueprint, and the first thing that we'll do is we shall get the number of spline points, and the reason we're doing that is because if I bring up a diagram, let me just quickly draw an example for you. I'm just going to create a new document here. And just 1 second, I'll be with you shortly. There we go. So if we can imagine that we have a spline, sorry, I'm just going to change my brush settings so it's easier to see. If we imagine we have a spline point here, a spline point there, and a third spline point, and the spline is connecting these three together, then what we want to do is we want to create a spline mesh component between each of these points. And what we're going to be doing is counting the number of points, working out how many spline mesh components we need, and we're also going to be grabbing the point locations and using that as inputs for each of these spline mesh components. So we'll have a spline mesh component across here and a spline mesh component across here, and we're going to be setting these starting locations and end locations, and also the tangent at each point along the curve, because you can imagine that the tangents, oops, let me just choose another color. The tangent here controls how this mesh is being deformed at this point, and the tangent here is going to be controlling the deformation of the mesh here, so that as the mesh component, spline mesh component, is deformed, it follows the curve. So I'll just move this across, and so first we'll get the number of points, and then we will create a for loop. So we shall right click and we shall create a for loop, and first index is going to be 0 because the first point of a spline is always 0, whereas the next one will be 1 and 2 and so on as the spline has more points. And we're going to set the last one to be the number of points in the spline. So what's going to happen is, as this for loop gets executed, it's going to start with the first point, go through to the next point, and then go through to the next point until the end. And at each time it does that, it's going to execute this pin. So in the loop body, what we're going to want to do is we're going to create a spline mesh component for each point. So instead of adding a spline mesh component and keeping it saved in the blueprint, we're going to be creating it on the fly, depending on how many points we have on the spline. So we'll have a spline mesh component between each point. So now we've created our Spline Mesh component. What we're going to want to do is set its end points and start points and tangents for each one. So first we'll drag out this pin, and we're going to set I'm not sure if this will show up straight away, but I'm just going to uncheck context sensitive, because sometimes when new features are added, the context sensitive menu doesn't show everything. So what we're going to do is under the Spline Mesh section, we're going to choose set start and end, and this is a function that will do this for each component. So as the loop is executing each time, it's creating a component, and then it's going to be setting the start and end point of, and you see the target is Spline Mesh component, so we have to give this a target, and the target will be the one that's created each time by this node. So we're just going to connect those directly. So now we need to find a way to get the start position and end position of each Spline Mesh component. So what we will do is we shall right click, and under the Spline section, I'm just going to type Spline to filter through. We see this node called a get local location and tangent at a spline point. So what it does is it takes a target, which is a spline, and it takes a point index. So we're going to be giving it our spline, and what we want to be doing is giving it a point index so we know which tangent and location we want to get. And the way we get that is simply by grabbing it from the for loop, because we're looping through each point. So at point 0 we want to get the point and tangent at that point in space. So we just connect the location to the start position and the tangent to the start tangent. And what that will do is, if we have a Spline Mesh component, let's say this is our plane from a side, it grabs the start location and tangent and sets it in this direction. But we also need to get the end position. So what we want to do is we want to get this point here, and the way we do that within our loop is we can copy this node. We can even drag in the same spline, because that's the spline we want to get, but we want to get the next point, and it's a really simple way of doing that. So we just drag out our index, type in plus, and we're going to be using the integer plus integer node, and we will simply add 1 to that integer, and that will give us the next point in the spline. So then all we do is we connect the start local location and local tangent to those tangents. So the only difference now is we want to set which mesh we want to use, which static mesh we want to use in the Spline Mesh component, because it needs to look at a static mesh. So we can come down here and choose it, or we can even just create another node under the static mesh category. We can choose set static mesh. We can connect these in between the executions, and the target that we want to set the static mesh on is our component, which has a static mesh within it. So then so what will happen is that each loop body, it will create a static mesh component, then it will go onto this node and it will set the static mesh, and all we need to do now is set the asset. So we can choose that. Now if we compile this, we'll see what's happening, because we want to see if our component is being executed. So we shall just zoom out. Now there's one thing that we're not doing here, and that is we are not connecting our construction script event to the for loop. So nothing will actually happen until we connect that event. If we can get this right, there we go. Compile, and we can see that it's actually doing something now. So what's happening here is that because the static mesh, it was at a different orientation when we exported it from the modeling program, that it's actually coming through at that orientation. So what we want to do is go to the Spline Mesh component, and there's actually a forward direction that we can change so that it should point the right way then. And I just want to make sure that I'm choosing the right one. I think that is the right one, but there is a few things wrong with it. One is the normals on the mesh, you'll see, are pointing the wrong way, and the other thing is that the mesh is being, there's an extra Spline Mesh component that is being added at the end and repeating back to the start point. So the first thing we'll do is we'll fix that. And the way we do that is we want to get the number of spline points, and we want to -1 from this, because that will cause there to be not as many mesh components added. So we're just going to subtract 1 and replace the index with that, and hopefully when we compile, nope, that's not the right way to do it. What we shall do is subtract 2. Is that the right one? Okay, so that's worked. So I haven't figured out why that's the case yet, but that's what we have to do, is subtract 2. Let's go back to our modeling program and let's see. That's why, because there aren't actually any faces there. I think what we will do is, let's start again. Let's create a grid. Oops. Let's scale it up. We shall select the faces, and we shall extrude these out. We shall do it again. Actually, the easiest way to do this is just create a cube. So we want width and depth is 8. Oh, that's the size. So we shall create width and depth of 8 as well. So that way we've got a cube. And we shall scale this out in these directions. And let's save selected objects, save over that same, and we shall re-import that. So now what we see is, just move this out of the way, we see geometry that is being deformed along the splines, and we can even grab the splines and move them around, and the mesh should follow. I have to mention that the deformation is completely dependent on the amount of geometry that you have in your original object. So if we go to wireframe, we can see that there's not much geometry along the length of here, so it's being deformed quite a lot, which is why it's causing some warping and little kinks here and there. But if we simply create more points by alt dragging on the spline, then we can minimize on the distortion. And you do notice that some of the tangents do get a bit messed up as we drag around, so you've got to be quite careful about how sharply these corners turn on this Spline Mesh, on the Spline component. Now the reason we can't simply just create a box and do the same thing is because it doesn't have as much geometry. If we created a box and from this box created a static mesh, and we shall create that just here. If we use that to be generated along the spline, we can come back here and go to our new static mesh. If we choose the box brush, compile and save that. Oh, I had a crash. I'll submit a crash report. I'm not going to bother opening up that again to show you, but because there's no vertices in between the endpoints, then there can't actually be any deformation. So you wouldn't get a nice smooth deformation of the points along the curve. But I hope that is enough to show you what you need to get started. And feel free to add any comments, and if there's anything you're unsure about, then I will try and clarify that if I can. Okay, thank you for watching. See you later.